Hi guys, in this video we're going to cover fractional distillation, which is an important part of topic 7, organic chemistry. But before we do so, let's recap some of the things we've seen in other videos. So the first one says, what is the general formula of an alkane? Now hopefully remember that it's CnH2n plus 2, and if you didn't, we're going to recap that again in this video, but if not, go back and have a look at the video on alkanes. The second question says, describe how increasing the surface area speeds up the rate of reaction. Well, actually increasing surface area speeds up rates because there's more sites that are available for a reaction to take place. And the last one says, what two types of elements form covalent bonds? That's non-metals. And if you didn't quite catch that, there's the answers for you to write down now. It's also important before we get into fractional distillation that we cover some of the more important parts of previous lessons so that we can use them to help us with this lesson today. What elements make up a hydrocarbon? Well, this is hydrogen and carbon only. Now it has to have the word only in there. There's lots of compounds and molecules that contain carbon and hydrogen along with other elements as well. So we have to say only if we talk about hydrocarbon. Crude oil is made from plankton or dead plankton. You can also have the keyword ancient biomass as well, but I prefer to remember the word plankton. And what is an alkane? An alkane is a hydrocarbon with only single bonds. And they look like this. We've got 4 there, and these are the 4 you need to remember. And I'm going to write down the names of each of them. If it has 1 carbon, it's called methane. If it's got 2, it's ethane. 3 carbons, it's propane. And 4 carbons, butane. Now what you should notice that all of them end in ane, A-N-E. And that's because they all belong to the functional group of alkanes. They all belong to that family, so they all end in the same way. You also need to know how to use that formula, if you remember, CnH2n plus 2, to work out the formula of any alkane you could be presented with when given the number of carbons. And we'll do one of those now, and I'll give you one to have a go at as well. So if we look at propane, for example, it would say in an exam that you've been given 3 carbons. What is the formula of the alkane? So I know that C is 3, so N equals 3 because I've got 3 carbons. If I wanted to work out the number of hydrogens, it's double the number of carbons plus 2. So double 3 is 6, add 2, that's 8. So H8, and that works out, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8. So that's the formula of propane. You try butane, pause the video, and then we'll reveal it for the answer. Right, hopefully you paused it and had a go. So it would say in the question that you had 4 carbons, so C would be 4. Use the formula, this time N is 4. So we double N and add 2. Double 4 is 8, plus 2 is 10. And that's all there is to it. And that might be 1 mark in an exam, but it's 1 easy mark if you can remember the formula. It's also important that we look at some key words linking to fractional distillation, because if we don't know what the words mean, how can we use them in an answer? When you do talk about fractional distillation, it's important to use the words evaporation, condensation, and boiling point in your answer as a bare minimum. So let's have a look at what some of them mean. Evaporation, well, this is when you turn a liquid into a gas. You heat it enough that it reaches its boiling point and it turns into a gas. Viscous, this is reserved for long molecules. That means when they are thick. Honey is an example of this, so something that is quite thick and not very runny, like honey, we would describe as viscous. Condensation, this is the opposite of evaporation. This is when a gas cools down enough that it turns back to a liquid. Flammable, this is a substance that is easy to set on fire. Fraction, this is just a section of what is removed from crude oil, and you'll see a couple of those in a picture in a second. And a column, this is the tube or cylinder that we do fractional distillation in, and it looks like that, okay? So what I'll do is I'll talk through some of the key points and then we'll formulate an answer together. So this is the fractional distillation column, and we need to know that it is hot towards the bottom and cool towards the top. Now we call this a temperature gradient, the fact that it's hot at the bottom and gradually as you move up it gets cooler and cooler. And what happens is you pump crude oil in and it's usually evaporated. So it's heated and evaporated. So we'll write that down now. So crude oil is evaporated and enters the column. Now, because crude oil is made up of a mixture of hydrocarbons of different chain lengths, what happens is these start to separate depending on their boiling point. So the longer chain, which have higher melting and boiling points, they stay towards the bottom. And the shorter chains, well, they go towards the top where it's cooler because they have lower boiling points. So let's write that in. So we're going to say that there is a temperature gradient, that the column is hot at the bottom and cool at the top. And because of that, the fractions or the different parts of crude oil basically condense at different points. So we're going to say the different hydrocarbons condense at different points as they have different boiling points. Now, before we move on to the last bullet point, I'm going to look at what we've covered so far. Have we included our keywords? We've talked about evaporation, so yes, there's one. We talked about the temperature gradient, that's a bonus mark, not one of our key ones, but it's an important one, that's 2. Different hydrocarbons condense, 3, and boiling point, 4. So out of those 3, what I said were the most important key points: the condensation, the evaporation, and the boiling point we've already included. So we should already have about 3 marks. The extras come from this temperature gradient and the final one I'm going to make here. So the final point which I want you to include is the fact that you get smaller ones towards the top because of the low boiling point, and you get larger hydrocarbons towards the bottom because of their higher boiling points, and that's important as well. Right, now let's look at the mark scheme and see if we got all the marks that we needed. So did we talk about the crude oil being evaporated or vaporized? Yes, we did. Did we talk about the temperature gradient in the column? Yep, we did. We talked about it being cool at the top and hot at the bottom. Did we say that the fractions or the hydrocarbons condense at different points depending on their boiling points? Yep, we did that as well, different boiling points. And finally, that final bullet point was all about where they condense. So the larger ones condensing at the bottom because they have high boiling points, and smaller ones condensing at the top because they have low boiling points. And before we end the video, let's do a quick recap of what we've covered so far. So let's start by looking at the top of the column. Well, at the top, molecules are small. They have low melting and boiling points. They are not very viscous because they're small molecules, and they are very flammable. At the bottom, these are the opposite. They are large molecules. They have high melting and boiling points, which means, well, as you'll find out, they're not very flammable, and they are very viscous because they're long molecules. So hopefully that helped today. If it didn't, or you need a bit more explanation, please pop it in the comments below and I'll respond when I can. But hopefully, see you next time. Bye bye now.